So I'm reviewing problem 332, which Allegra did. For the project, you're given a good amount of information: the temperature of the sky, general temperature of the air outside, general temperature of the inside the house, area of the roof with K, emissivity, and thickness, as well as H values of the inside and the outside for the radiation. Or sorry, not the radiation, the convective resistance. So overall, it's going to look like this. You have two parallel, or two in series, and then two parallel, and then in series. So these two are in parallel series with this, and these two. Outside the roof, the inside, and heat goes from inside to outside. And so that's basically the flow. And you know that the heat going into the roof is going to be the same as the radiated heat and the convective heat transfer to outside, but equal and opposite signs. And so you can plug all this information into Excel, including the H radiation term, Q convection term, Q for the roof, as well as H for the resistance for the roof, H radiation, and H total for the inside. And you can all use it to find the temperature, the temperatures of inside and outside using this equation. And use this equation to find the inside temperature, plug that into this one to find outside temperature. So again, you make the bottom cell here equal to 0. You solve for to change T1, which is proportional to or relevant to T not outside. Find in the Excel solver, it pops out these numbers: -2 degrees Celsius on the inside. That should be on the outside. Outside, I labeled that wrong. So it's -2 on the outside, 7.3 on the inside, with a heat transfer of 37,000 watts going through the roof. And then finally, you have an efficiency of 0.8, and you try to find the amount of money it costs of the heat going through. And such as a unit change kilowatts to kilojoules, get the times for 14 hours, and then cross out the therms, which is correlated to kilojoules, and cost $26.08 to heat the house overnight.